Hello everyone, and welcome to another homework solutions video. This week we're going to start with question number 2 from the homework. So question 2 is from page 576 of the textbook, problem number 26, and it says Parasaurolophus was a dinosaur whose distinguishing feature was a hollow crest on the head. The 1.5 meter long hollow tube on the crest had connections to the nose and throat, leading some investigators to hypothesize that the tube was a resonant chamber for vocalization. If you model the tube as an open-closed system, what are the first 3 resonant frequencies? Assume a speed of sound of 350 meters per second. So let's write the relevant information on the board. We have an open-closed tube, and we're using V equals 350 meters per second for the speed of sound in air. Now for an open-closed tube, our frequency is given by the equation F sub m is equal to m times V over 4L. So in the case of an open-open or a closed-closed tube, we have a 2 in the denominator instead of a 4. So that was one thing I noticed on the homework, is some people use a 2 here, but since it's open-closed tube, we have a 4 in the denominator. Now the other thing to note about the open-closed tube is that the first 3 resonant frequencies are going to be modes 1, 3, and 5. So a lot of people use 1, 2, and 3, which is what you would do for an open-open or closed-closed tube. But for open-closed, we don't have the even number 1, so we only have the odd number. So the first 3 resonant frequencies are going to be modes 1, 3, and 5. So F1 would be equal to 1 times our speed is 350 meters per second. And the length was 1.5 meters, I believe. Yes, so it's a 1.5 meter long hollow tube. And so we plug this into our calculator, and we get this is about 58 hertz. So to get our next frequency, we're going to have F sub 3 is equal to m times F sub 1. So we could have used m times V over 4L, but since V over 4L is the same each time, we can just use F1 instead. So we're going to have 3 times 58 hertz, which works out to be about 170 hertz. Now, lastly, F5 is going to be m times F1, which is going to be 5 times 58 hertz. And that works out to be about 292 hertz. Now we're only using 2 sig figs throughout this problem, and in fact we probably should have kept one more here and here. So this one we're going to round to 290 hertz. So that's the solution to question 2.